Welcome back to The Explainer. Now, for those of you who've been with us on this journey through Vedic mathematics, you know these sutras are packed with some serious power. But today, we're diving into Chapter 5. And let me tell you, this is something else entirely. We're looking at a division technique that's hailed as the very peak of the whole system. So if you thought the other methods were slick, this is where things get really interesting.
You know, the source text does not hold back. It calls this method the crowning gem of all the sutras. I mean, wow, that's a huge claim, right? This isn't just another neat trick for doing math in your head. This is being presented as the absolute top tier, the best of the best. So, what on earth makes it so special?
Well, a picture's worth 1,000 words. On the left, you've got the long division we all wrestled with in school. You know, all that scratching down, multiplying, subtracting. It's just a lot. And then, on the right, you have the Vedic way. Look how clean that is. It just promises a tidier, faster, and frankly, more beautiful path to the exact same answer. It's about trading all that clutter for pure elegance. Let's see how it's done.
Okay, so here's our game plan. We're going to start with the basics, using simple two-digit divisors. Then we'll level up and see how this thing handles bigger numbers. After that, we'll learn how to get super precise decimal answers. And then, this is the best part, we're going to pull back the curtain and see the incredible logic that makes it all tick. And we'll wrap up with a final question to chew on.
All right, let's dive right in. Section 1, the basic method. We'll get our feet wet by mastering those two-digit divisors first.
So the very first concept you need to get is this thing called the dwajanka, or the flag digit. The whole method really hinges on this one simple, clever move. We split our divisor. For a number like 73, we take that last digit, the 3, and we kind of set it up on a flagpole. That's our flag digit. We'll use it for making these little corrections along the way. The rest of the number, the 7, becomes our new, much easier main divisor. This simple split is the secret sauce.
Okay, so here's the play-by-play. First, we just divide the first chunk of our number by our main divisor. So 38 divided by 7. That gives us the first digit of our answer. But now, here comes the key move. Before we do the next division, we use that little flag digit to make a quick correction. That gives us our actual dividend. And from there, you just repeat the loop. Divide, correct, divide, correct. See that rhythm? It's what lets us skip all the huge multiplication and messy subtraction of the old way.
And just by following that simple loop, there it is, our answer, a quotient of 534 with a tiny remainder of 1. Think about what we didn't do. No big, clunky calculations. It's just a clean, straight line to the solution.
And you know what's really cool? Vedic math has this awesome built-in way to check your work in seconds using digital roots. There's this simple little formula that has to be true for the answer to be right. We just plug in the digital roots from our problem, and, yep, 3 equals 3. It checks out. It's like an instant sanity check that tells you you've nailed it.
All right, Section 2, handling the big guns. Any method is only as good as its ability to scale up, right? So what happens when we're facing a 3-digit divisor? Well, this is where we introduce the crosswise or Tiriac step. This is what makes the technique truly universal.
The basic idea is exactly the same, but our correction step gets a little upgrade. With a divisor like 578, we now have 2 flag digits, the 7 and the 8. This means our correction is a cross product. You can see right here how it works. We do this neat little cross multiplication with the digits of our answer and the flag digits. In this case, our correction value turns out to be 21.
Now let's see this in a full-blown problem. This slide is breaking down how we get each actual dividend. You can see that cross-product correction happening at every single stage. Now I know it might look a bit complicated written out like that, but the pattern is perfectly logical. It's the same rhythm we learned before. Divide, correct. We've just added that Tiriac step to the correction part.
And boom, following those steps, we get our final answer, a perfect 322 with no remainder, clean as a whistle. This just goes to show you how beautifully this whole method scales up, handling much bigger numbers with the exact same elegant approach.
On to Section 3. So, remainders are great, but what if you need more? What if you need to get a precise answer down to the decimal places? Well, the beautiful thing about this method is you don't actually have to learn anything new. The process is almost identical. You find the whole number part of the answer first, just like we've been doing. Then, to get the decimals, you just stick a decimal point on and start adding zeros to your number. After that, you just keep going. You just continue the exact same divide and correct loop that you've already mastered. The engine is the same, you're just letting it run a little longer.
And if we keep that process going for a few more steps, we get an answer of 4.2308. From there, we can just round it to whatever precision we need, like 4.231. It's the same core technique, just giving us incredible accuracy. Okay, section 4, the logic. So far, this has been an amazingly effective process. But, it might feel a little bit like magic, like a clever trick. Well, it's not. And in this next part, we're going to pull back the curtain and see the absolutely beautiful logic that makes it all work. And that's a fair question, right? When you see something that works this well and feels so different from what you're used to, it's totally natural to be a little skeptical. Is this just a shortcut that only works for certain problems? The answer is a huge, resounding no.
Okay, so take a look at this calculation from the source text. I want you to pay very, very close attention to that highlighted row at the bottom, the actual dividend line. See those numbers? 6, 12, 11, 0, and 5. Got them? Just burn those into your memory for a second.
And here is the big reveal, the secret. This whole method, this isn't just a trick with numbers. It is a physical, mechanical way of doing algebraic polynomial division. Seriously, if you imagine our number is just a big polynomial where x equals 10, then the Vedic process is identical to dividing it algebraically. And those actual dividends we just looked at, they are the exact same coefficients that pop out during the algebraic division. This isn't a shortcut. It's profoundly efficient algebra in disguise.
So we've seen how it works, we've seen how powerful it is, and now we've seen the beautiful logic behind it. And all of that brings us to one last, really compelling thought.
This just leaves us with a fascinating question to ponder. If a system like Vedic mathematics has such a powerful, logical, and just plain better way of doing something as fundamental as division, it really makes you wonder, doesn't it? What other elegant solutions, what other powerful knowledge might be out there, just waiting for us to rediscover it? Thanks for joining us on The Explainer.